Okay, this is design assignment 4A. The instructions are to configure the DC motor to work on and off, turn on and off at the push of the button on the shield. And when the motor is running, we want to be able to adjust its speed using PWM, reading the output of a potentiometer through the analog to digital converter, and using the output of the analog to digital converter as the value of our output compare registers. So here we have the motor driver configured. Our motor's hooked up here to a little fan, and we're powering the driver with a 5 volt DC power supply, constant 5 volts, 2 amp limit. And here we have our signal connected to PV1. That's connected to the input of the driver. Our top level C code is running, and if we turn the fan on, we'll see that it runs. Turn it off with the button also. This LED is also configured to turn on when the fan turns on and off when the fan turns off. And what you'll see is if we actually, right now it's at full speed, if we actually change the potentiometer over here to have a different resistance, the speed will be much slower. Oh, too slow. That's too much. Try this. Still too slow. There we go. A little slower. And if we turn it all the way, it'll turn off when we press the button. So the LED's on, but the motor actually isn't running. And then if we turn it back, we'll see that it runs again. So now we'll actually configure the oscilloscope instead of the motor to actually see the pulsed width modulation in action. So here's the signal. Here we go. Right now we can see that the duty cycle is pretty high. We will turn this off, change the value of the potentiometer, and the pulse width should get much lower. And there it is. And if we turn it all the way off, the pulse width modulation will be all the way off.
Studio? ML Studio?